Right, now let us learn how to derive the formula for thin films. Okay, so as we can see, yeah, we learned earlier on regarding this one. Okay, yeah, this one. Okay, last time we learned that interference has two. One is double slit, and then second one is the thin film. Double slit is always in phase source, yeah, in phase source. But thin film, it has two category. It has in phase and it also has anti phase. Okay, so in phase, if in phase, we know that if in phase, like the double slit in phase, the bright fringe, to form the bright fringe, the path difference is m lambda. To form the dark fringe, the path difference need to be m plus half lambda. For the category of antiphase thin films, antiphase, to form the bright fringe, the path difference will be m plus half lambda. The dark fringe will be m lambda. So thin films has two categories, in phase and antiphase. So now we need to know how come we have two category for thin films, whereas for double slit only has one category, in phase. For thin film, it has two categories, in phase and anti-phase. What causes in phase and anti-phase for thin film? We need to investigate that. Okay, so it has two categories for thin films. Okay, let us learn the first one. Okay, the first one, the in phase. So what things cause brings this category of in phase to thin film? Okay, two sources in phase. Two sources in phase means reflected light with no phase difference. What does it mean? Yeah, it regarded about the reflected light with no phase difference. If this reflected light, these two reflected light has no phase difference in between them, that means they are in phase because they have no phase difference. Okay, what causes them in phase? First of all, as you can see here, we have two categories. One is the two sources in phase, and then the next one is two sources anti-phase. So the impact is for in phase, to form the bright fringe, the path difference is m lambda. You see that? M lambda. Dark fringe is m plus half lambda. And for the anti-phase, just like the one we learned very earlier on about this, the path difference in phase and anti-phase. You see that? If in phase, delta L must be m lambda. The bright fringe must be using m lambda. Dark fringe is m plus half lambda. So the same as this one lah. You see? For in phase source, the bright fringe will use m lambda. Dark fringe will use m plus half lambda. But for the anti-phase, if you see, for anti-phase, the bright fringe will use m plus half lambda, just the same as what we have learned earlier on this one. Yeah. If anti-phase, the bright fringe use m plus half lambda, dark fringe use m lambda. You see that? Bright fringe use m plus half lambda. So the same as this one. See that? Anti-phase, bright fringe use m plus half lambda. Dark fringe use m lambda. Maybe I should take this picture and copy this, carry here. So easier reference. Yeah. Put it here. Okay. Like that. So maybe drag it a little bit bigger. Okay. See that? If in phase, bright fringe is m lambda. You see that? Yeah. In phase, bright fringe is m lambda. And then if anti-phase, bright fringe is m plus half lambda. Okay. If anti-phase, see, anti-phase, m plus half lambda. So and then dark fringe also like that. Okay. So thin films has two categories, in phase and anti-phase. So now we need to investigate what causes in phase sources and anti-phase sources. Okay. So the first one. Okay, let's look at the first one, in phase source. Okay, you have learned about the phase change, isn't it? you have learned about the phase change. Phase change, this is also very important. Phase change means maybe I should just okay. Phase change only happens during reflection from lower to higher refractive index. That means it's just like this one lah. From air to glass, reflection, we have phase change. All the other condition, no phase change. You see that? Like this one, see? Phase change only happen, yeah, you see only this one is red color. The rest is not. The phase change only happen from lower refractive index going to higher refractive index, the reflection. Here got phase change. The rest, no phase change. So you see, the refraction also no phase change. So look at this one. What is phase change? Phase change means like this one. This one has phase change. The wave is actually initially going up, but when it's reflected from a fixed end, the wave goes below. You see that? The wave goes below. That is called phase change, inverted, or we call it phase inversion. Invert 180 degree or pi radian or half lambda. Okay, so now let's look at this one. Okay, let's look at this one. Okay, so now we have thin film. Okay, thin film is actually a coating. Okay, just want to write something here. 1 second. Okay, now yeah, write all this. Okay, this thin film actually is a coating. You know what is a coating? A coating means something protecting a coating means a coat that protect a surface. So, like for example, like this one. This the middle one. Yeah, normally coating is at the middle lah, the middle layer. Yeah, if in the diagram we can see it as a middle layer. So you see here we have 3 layers, isn't it? The middle one is the thin film. This one, the middle layer is the thin film. Understand? The middle one is the thin film. Is actually protecting the surface below. Like this case, this one is actually like, you see, lower refractive index going higher and the highest. So we can say, maybe you can put example. This one is just like from air going to water, going to glass, something like that. From the lowest refractive index going to higher, and then the highest. So the water is like a thin film for the glass, like a coating for the glass. Okay. It also can be like this one, oil film on water. Later I will talk about this oil film on water. Okay, so you can see the center one, the water become the thin film. Okay, so like this case, from low or what we can say, from low refractive index going higher, okay, and then highest. Yeah, from low refractive index going higher refractive index, and then going highest refractive index. This one will brings 2 in-phase sources. The reflected light, you see this is the reflected light. They have no phase difference. These 2 reflected light will be in phase. Why like that? Because about the phase change. You have to know about the phase change. Reflection, it only happens during reflection from lower to higher refractive index. Let's look at this one. Okay, so now you see here we have 2 reflected light from this surface. Okay, these 2 reflected light, they are in phase. Why they are in phase? Actually, these 2 light, they originate from the same source. They originate from one source of light. Okay, maybe I can draw over here. So here I have this is the okay, this is the air, water, and then finally is glass. Okay, now you see this light it comes draw like that. Okay, the light comes here. Okay, part of the light is reflected. We know that 50% of light, okay, is reflected. Another portion of light is refracted. Not all the light go into another medium. Part of it reflected, part of it go into another medium. Okay, so we have 50% of light reflected, 50% of light refracted, go into another medium. So I just want to rub this off. Yeah, I don't need this. Okay, this is the incident light. Yeah, I can say this is the incident light. So part of it reflected, part of it refracted into another medium, and then the second light, this second light also being reflected, okay, being reflected and then refracted. Yeah. And then this light, this light which is reflected will also reflected again, and then part of it reflected, part of it reflected, and then go out. Yeah. But for our syllabus, we don't learn about this. Is the transmitted light. The below one is called the transmitted light, and then this is the reflected light. You understand that? This is the transmitted light and this is the reflected light. But we don't learn about the transmitted light. We only learn this part. We only learn about reflected light. Because for STPM level, if the STPM students, they will learn both of this. That's for STPM students. But for matriculation level, you don't need to bother about this transmitted light. You don't learn about this. You only learn about this. That's for matriculation. You understand? So I can say matriculation students are very good lah. They are very fortunate. Yeah. So they no need to test it on this transmitted light. They only tested on this reflected light. Okay, but that's the thing. Anyway, actually there are two cases. Yeah, not just the reflected light, there are also transmitted light. We can imagine like something like why we need to know about the transmitted light also, because it's like a window. We can say like a window pane. This is like a house. You see, this is like house. Okay, the window. You know the window. This is the window. Okay, the window pane. The window also has a thin film. You know that the window also has a thin film. So the person inside the house, will see what? You know, the sunlight comes. This is the incident light. Okay, this incident light, part of it is being reflected. Part of it is being reflected, part of it is being transmitted. Transmitted for the person to see. So this is the window lah. So what the person see is the transmitted light. But what the other person from outside see, what other person from outside see is the reflected light. So the transmitted light is for the person. Inside the house. The reflected light is for the person outside the house. So you can see sometimes some window they have certain thin film like this one. Okay, like this one. We see this case. Some window from the person outside. The person outside cannot see through the window glass because of the window film, the glass thin. Because it's being protected by a thin. This window has a thin film. That you know. This is thin film. This is application of thin film. The person from outside cannot see through the window. We call it reflective coating. So we are now going to learn about this reflective coating and non-reflective coating. So the person from outside cannot see into the house. It is because of thin film. It's because of thin film. Yeah. The person outside. Because it has a reflected light. You see. So it has a reflected light, so the person cannot see inside the house. The transmitted light is the person inside the house. Like you see, the person outside cannot see into the house, but the person inside the house can see outside of the house. So that is the difference between transmitted light and reflected light. Same thing also like our glass. You know, our glass. Like the person, you see this one. This woman, it has this is using non-reflective coating. So what I say, you have reflective coating and non-reflective coating. Why? This is that's why I say thin film has two cases. Thin film has two cases. It has the two source with in-phase source and also two source with anti-phase source. The two sources with in-phase then can produce the non-reflective coating. The one with two sources with anti-phase can produce the reflective coating. That's the difference between the glass lens and the window glass. So like this one, you see, this one is reflective coating, so you cannot see inside the house. But this one is non-reflective coating. You can see the eye of the person clearer. Yeah, reduce the glare, so that you can see the person with nicer look. Yeah, because no reflected light, destructive interference. So you can see the eye. So this one also has yeah, why you can see the eye of the person clearly? Because the no reflected light. Because the reflected light is being reduced. The reflected light is being reduced. So the person, the third person looking at this woman, like me looking at this person, like me looking at this woman, I'm the person who looking at the reflected light. Okay. So if the woman himself is looking through the lens, looking to the world through the lens, he is looking at the transmitted light. But in your matriculation, you don't need to learn about this transmitted light yet. If you have interest, you can look through the internet, yeah, to study more about this transmitted light. Actually, it behaves the same thing. Behaves the same thing like the reflected light. You have to know about this transmitted light is in phase or anti-phase, to know whether how to produce the bright fringe and dark fringe and so on. Understand? Okay, now let us just focus on our matriculation about the reflected light. So what we can say is we no need to consider about this. We just want to know about these two light. We just want to know about the reflected light. So we just want to know these two light. So what we can ignore the below part. Transmitted light we can ignore, although it still happens, but we just don't learn it because it's not in our syllabus. Yeah, it's not in our syllabus. Our syllabus is just learning about reflected light. We don't learn about transmitted light in thin films. Okay, so we can just ignore this part. Okay, just ignore this part. No need to learn about the transmitted light. All right. Okay. This one also no need. Just this one. We just learn about the reflected light enough lah. Okay, these two light, they originate from the same source. Remember, these two light originate from the same source. And another thing, before we venture even further, this light actually is not coming at an angle. Actually, it's coming normal. Yeah, one thing, to avoid misconception. Actually, this light is incident normally. Yeah, actually this is a normal incident light. What I can say, this is a, you know what is normal? Normal means 90 degree. It comes 90 degree. It don't comes at an angle less than 90 degree. It comes at 90 degree exactly. But we draw it slanting so that we can see the both light clearer distinction. We can distinguish these two light clearer, because if we draw really light normal incident light, if we really draw normal incident light, it becomes like something like this. It becomes something like this. This is the normal incident light. it comes, part of it is reflected, and then part of it is transmitted, and then part of it is reflected again. How do we distinguish them? Actually, this is the actual case. This is the actual case. The actual case is this one. This is not actual case. Yeah, this is not actual. This is not actual case. But why? But why we draw the line and an angle like that? When we draw the angle, this is not actual case. But why we draw the, why do we draw the angle like that? Because if we don't draw like that, how do you distinguish between 1 and 2? If we draw like that, like this, how do we distinguish between 1 and 2 light? Cannot. Yeah, there are 2 reflected light, but we cannot distinguish them. Very hard. This is the actual case. Actually, it's a normal incident light coming at 90 degree, but we don't draw like that. We just draw like that. So for easier understanding, because we want to separate the 2 light clearer so they can see clearer. Okay, but why do we? Why I still want to let you know about the actual case? That is because of the path difference. The path difference. The path difference, I will tell you later on about the delta L. It's because of the thickness. The thickness is exactly the 90 degree light. This is the thickness of the thin film. This is the thickness of the thin film. The extra distance traveled by the second light is actually 2 times the thickness. Yeah, and this is the refractive index for the thin film. Okay. Okay. That's why I still tell you about the actual case. It is because I have reason for it. Because you see. Let me tell you about the path difference first. Yeah, path difference first. These two light we can say originate from the same source. Yeah, originate from same source. But you see here, you can see the first light. Here you can see the first light, and this is the second light. Yeah, it divided into 2 light, isn't it? The incident light is divided into 2. We don't talk about the transmitted light. Yeah, there are even more things to know. But this light, the one light incident light is being divided into 2 light. One light divided into 2 light. So these 2 light originate from the same source. So is this coherent? One more thing. Are they coherent source? Are these 2 light coherent? Are they coherent? Or can I say that they have same wavelength? Of course, they are actually come from the same light. So if this is like this one is the blue light, the incident light is a blue light. So the one reflected is also blue light, blue light, and blue light. So they are coherent. There are 2 coherent sources of light. 2 coherent sources. Why we say like that? Because they have the same wavelength. Or we can say monochromatic. Same thing like the double slit. Yeah. Why we say these 2 light is the coherent? Because they originate from the same source. They originate from the same one source of light. Same one source of light. They originate from the same source. These 2 light originate from the same source. That's why if this the source of light is actually blue light, so the 2 light which is reflected is also blue light. So they can say they are coherent. They have the same wavelength. That's one thing. Now I want to talk about the path difference. So what is the extra distance? You can see the first wave. The first wave has a shorter distance. You see, going from here, and then the first light is just this short. Okay. Maybe I want to distinguish them. This is the first light. You see, this is the first light, and this is the second light. The second light is maybe I should draw like that. Use another color. Okay. This is the second light. Which one travel longer? The first light or second light? Of course, it's the second light travel longer distance. By how much? By how much? This part lah. This part is the extra distance. From here to here, here to here, they have the same distance, isn't it? This part is the path difference, the extra distance by wave 2, which is this is the delta L. Understand? This part. This part. So actually, this light is not coming at an angle. Actually, the actual case is the light is incident. Normally, it's actually normal incident. Actually, it's the normal, yeah, coming at normal, or not the normal. It's the normal here is means 90 degree. This light is normal incident. So this the path difference is this part. You see that this part? This is the delta L. This is the delta L. So how much? What I can say? How much is the extra distance? How much is the extra distance traveled by the second light? How much is the extra distance traveled by the second light? Yeah. You see? We can ignore this part here, this part, and this part here. We can ignore. We just look at the part at the thin film. Yeah. The water is the thin film. You understand that? The water is the thin film. Yeah. So this part is the path difference, the extra distance. So you can see the second light. The path difference is going into the water, going through the water into the water, and then going out of the water. Or we can say this is the actual case. Actually, the light actually go into the second light. Actually go, the second light, it go into the water. Yeah, going through one thickness of the thin film, and then another thickness of the thin film, going to and fro. To and fro. 2 is one thickness of thin film, and then fro, one thickness of thin film. So there are 2 thickness of thin film it travels. So that's why I can say the delta L between these two light, the delta L between the delta L between these two waves is 2 thickness of thin film. 2 thickness of the thin film. And then you must understand this thin film, the refractive index, it has refractive index. Maybe water refractive index is maybe the water refractive index is the thin film. The refractive index is 1.33. So the thin film is not equal to 1. If air, the thin film, the refractive index is equal to 1. But for the water, the thin film, the refractive index is 1.33. So the path difference, delta L, is not just 2 times T. It's not just 2 times T. You have to multiply the refractive index of film itself also. You have to multiply the refractive index of the film. So the path difference will become 2nt. 2nt. These two is the so the path difference is actually 2nt. 2nt. This n is taking refractive index of the thin film, and T is the thickness of the thin film. Why 2? Why 2? Because the light of the second light going to and fro, going one thickness of thin film and another thickness of thin film as it return back to the surface. You see that? Going to and fro. Going to and then fro. Yeah? It going one thickness of thin film and then another thickness of thin film. So there are 2 thickness of thin film it travel for the second light. So between these two light, the path difference is 2nt. So now you already learned about this. The path difference between these two light is 2nt. That's what it means. Okay, now what causes them in phase or anti-phase? Okay, now you also know these two light, they are coherent because they originate from the same source, same lambda. Blue light or blue light, Okay, now let's look at this. Why are they in phase or anti-phase? Are they in phase or anti-phase? Let's look at this one. Yeah, I can say is here you can see phase change. Phase change, when is happen? Maybe I should draw like that. Yeah, maybe I should draw another one here. Yeah, easier to explain. Phase change. Okay, maybe later on. Okay, look at this one. Okay, phase change. Let's look at the first light. Let's look at the first light. You see the first light. This is the incident light. I should label this as the incident light. Okay, the incident light. The incident light comes and then being reflected. Part of the light being reflected. You see, reflection from lower refractive index. This is the low going to higher refractive index. Reflection. Is there any phase change for the first light? For the first light, is there any phase change? Yes, because it belongs to the reflection from lower to higher refractive index. Reflected from lower to higher refractive index. So got phase change. From here, from air to water, reflection got phase change. Here got phase change of That's why I write as pi radian. The first light got phase change pi radian. So how about the second light? You see the light. Okay, just now I'm talking about the first light is I'm talking about this path. I'm talking about this path. That means from here, and then go here. This is the first light. This is the first light. This one got phase change. The first light got phase change pi radian. Now the second light. Let's cut through this one. Okay, now the second light. Let's talk about the second light. The second light going like, okay, starting from the incident light also. Starting from the incident light, go into the second medium. Transmitted light from air to water. Is there any phase change? From here going to here. Is there any phase change? No phase change. Refraction from air to water, from air going into the water, no phase change. But then from here going to here, reflected light, water to glass, lower refractive index going to higher refractive index, 1.5 going to 3.5. Reflection got phase change. Yes, there is a phase change. It's just like it meets a fixed end, a hard surface here. It meets a hard surface here. So here got phase change. How many time wave phase change for second light? One time already. Yeah, one time phase change. And then the light going out. Is there any phase change from air, from the light going from water to air? Is there any phase change? No phase change. Refraction, no phase change. So for second light, how many time phase change? One time over here. You see that? Okay. So that's why for second light got also phase change of pi radian. So okay, again, let me do one by one. You see the first light. Let's look at the first light. For the first light is okay, you see first light comes here. Reflection got phase change. How many time phase change? One time. Over here got phase change one time. First light got phase change one time. Reflection from lower to higher refractive index, got phase change over here. One time phase change pi radian. Now for the second light. Let's look at the second light. Okay, let's look at the second light. Now the incident ray comes from air go into water, got phase change. From air go into water, got phase change. Refraction, no phase change. Zero. And then from water reflected from glass. From water reflected from glass. It's just like from air reflect from water. You see that? From water reflect from glass. Got phase change? One time phase change. Second light got one time phase change. Okay, one time phase change already. And then from water go to air. Got phase change? Refraction from water to air. From water to air. Got phase change? No phase change. So second light, how many time phase change? One time phase change also. So same like the first light, got one time phase change. Second light also got one time phase change. So what is the phase difference between them? So both got one-time phase change. So this make them in phase or anti-phase. It's just that we can imagine things like this. We can imagine things like this. You see, maybe this one is clearer. Both originate from the same source. You see, I just draw like that. Yeah, I just draw like that. Okay, both originate from the same source. Okay, both originate from the same source. I can say both like that. Yeah, both are like that. Let's draw like that. Yeah, clearer. Both come from the same incident light. Okay, both come from the same incident light. Okay, come from the same incident light. Now the first light, yeah, just now the green one, the first light got one-time phase change, isn't it? Got one-time phase change. So it becomes one-time phase change, yeah, from air to water reflection got phase change. So it one-time phase change, yeah. The first light got one-time phase change, pi radian. That means the light becomes invert like that. One-time phase change. Understand? And then that's for first light. For second light, the second light, the blue one. Okay. So let's look at the second one. How many time phase change? Where it occurs? It occurs when it reflected from water to glass reflection. Here got one time phase change. So how many time phase change for second light? Also one time, isn't it? Also one time. So that's why this one also one time phase change. That means it also invert below. So you see, are they in phase? Initially, they come from the same source, isn't it? They come from the same source. Both is that means if we say both come from the same source, means both is going up initially. But then both has one time phase change. The first light got one time phase change. Second light also got one time phase change. Both become inverted below. So in the end, are they in phase? Yes, they are. Conclusion: it is both become in phase. Both are in phase. So what I can say is the phase difference between them is like delta phi is equal to pi minus pi. What I can say is this is the first light, the pi radian for first light, and then this is the pi radian for second light. Pi radian for first light and pi radian for second light minus 0. So in between them, there's no phase difference. So we can say 0 radian. These two reflected light is like pi minus pi becomes 0 radian. Pi minus pi, 0 radian. So we can say these two light, 1 and 2, has no phase difference. We can say they are both in phase. Understand? That's how it works. They are both in phase. So now that's why we know this the first category, how we can get two in phase sources. Because both light encounter one time phase change. Both encounter one time phase change. The first light encounter one time phase change. Both second light also encounter one time phase change. So they both invert one time. In the end, they become in phase lah. Understand or not? They become in phase. Understand? Actually, we don't look at the end. Actually, we look at here. Actually, we are talking in phase, not at the end, but we are talking in phase at the beginning. I should write like that. We are talking in phase at the beginning. Like over here. So we are actually not talking about in phase at the end. We should actually talking in phase at the beginning. Because in the beginning they become in phase. In the end, maybe they are not in phase because of the path difference. Because of the 2nt, the wave 2 is travel even longer distance. So the path 2 is travel even longer distance. So they maybe end up anti-phase. Understand or not? They maybe end up anti-phase. In the end, the wave 2 travel longer distance, maybe they end up antiphase. So they also cause destructive interference. So I want to say is both encounter one-time phase change. In the beginning, they become in phase. This is in phase at the beginning. They in phase at the beginning. In the end, they maybe become antiphase to form either bright fringe or dark fringe. Understand or not? Okay. In the beginning, become in phase because both encounter one-time phase change. Okay, I hope you are very clear about this. Now, so the first category is about in-phase source. So in-phase source, the bright fringe use m lambda. Remember, for in-phase source, bright fringe use, the delta L is m lambda. The dark fringe use m plus half lambda. So that's why it happens. Yeah, for in-phase source, the bright fringe. So what's the path difference? Path difference is 2nt. 2nt. So just now I say what? For in-phase source, bright fringe use m lambda, delta A equal to m lambda. So I can write like that. I can write like that. This one here. This delta L equal to m lambda. Okay. For in-phase source. Okay. For in-phase source, bright fringe delta A equal to m lambda. Dark fringe. For in-phase source, bright fringe delta A m lambda. Dark fringe delta A equal to m plus half lambda. So dark fringe is delta L equal to m plus half lambda. Okay, m plus half lambda. So delta L is equal to 2nt. Still remember just now we learned about the delta L. Delta L is 2nt. 2 times thickness multiply the refractive index of the film. Is 2nt. So 2nt equal to m lambda. Yeah, that's why bright fringe formula is 2nt equal to m lambda. Dark fringe formula is 2nt equal to n plus half lambda. Yeah, just substitute the delta L with 2nt. Delta L with 2nt, and this one delta L with 2nt. That's how we get the formula for in-phase source, refracted light with no phase difference, bright fringe or dark fringe formula. Okay, and then this non-reflective coating, why it refer to dark fringe? And what about this one? Thickness not equal to 0, the order 1, order 0. I will talk about this later on. Yeah. Yeah. One thing is yeah, I will talk about that later on. Okay. So stay tuned for my next videos. Okay. Bye.